Alright, so today we're going to talk about matrices, and you should remember that a matrix is basically a system of rows and columns. It helps us to solve various problems, and it organizes numbers and data so that each position in that matrix is going to mean something. We did a little bit with matrices last chapter when we dealt with Cramer's rule. So in algebra, a matrix is not necessarily a table, but it's an array. And each value in a matrix is called an element. So let's look at a sample matrix here. If we had 3, 2, -2, 1, 1, and -4. That's our matrix. Each value in this matrix is called an element. This matrix is made up of a certain number of rows and columns, and this particular one has 3 columns across, and it also has 2 rows. And a matrix is usually named by using a capital letter, so we might call this something like T. And we can use a subscript down here to give its dimension. So since this has 2 rows and 3 columns, we can say it's a 2 by 3 matrix. Now, there's a couple special matrices. A row matrix is a matrix that only has one column, or I'm sorry, one row, and a column matrix is a matrix that only has one column. Just to give you some vocabulary words. And then if it has the same number of rows, for instance 2 rows and 2 columns, it's called a square matrix. Now, but what we're going to talk about here is equal matrices. So let's take a look at an example. Say we have a matrix 6x and y here. We want to set that equal to 62 plus 8y and 6 minus 2x. So if we say these two matrices are equal, that means every element in the first matrix has to be equal to every element in the second matrix. So in that case, this element needs to be equal to this element needs to be equal to this element. We can use that information to solve for x and y. So that's our directive here, is solve for x and y. Well, we know that 6x equals the element in the second matrix, 62 plus 8y. We know that this element y in the first matrix equals the element 6 minus 2x in the second matrix. So here, if we rearrange those, we can use any method we want to solve for x and y. But to me, substitution is the easiest here, because I can take what I have for y and plop it right in for this y here. So we'd have 6x equals 62 plus 8y, or 8 times 6 minus 2x. Again, getting that from the bottom equation. So let's simplify. 6x equals 62 plus 48 minus 16x. 6x equals 110 minus 16x. Let's add 16 to both sides. We get 22x equals 110. If we divide both sides by 22, we get x is equal to 5. So once I know x, I can just simply find y by saying y is equal to 6 minus 2x, or 6 minus 2 times 5, or 6 minus 10, or y is equal to -4. So I have a point at 5, -4 for my final answer. Now, another thing we can do with matrices, not only can we set them equal to each other, but we can also multiply them. So let's talk about what's called scalar multiplication. Now, a scalar is just a value or a number, and we're going to multiply the entire matrix by that number. Right, so let's say I have a triangle that we'll make a graph here. I'll do my best to draw a straight line. So let's say we have points at A is 3, 2, so 1, 2, 3, 1, 2 is A. B is -2, 1, so right there. And C is 1, -4, so right there. And these three, of course, make a triangle. So get my line tool. Alright, so now I have a triangle. What I want to do is I want a perimeter that's twice the perimeter of the original. And how I can do this is through scalar multiplication. I can create a matrix for this that represents the triangle by putting each point of the triangle in the matrix. So let's make a matrix here. We have one point which is 3, 2. We have a point which is -2, 1, and we have a point which is 1, -4. And if I want to double this in size, I'm going to multiply that whole matrix by 2. And I'm going to get, what I do is I just multiply every element. So if my first element is 3 in this one, it's going to be 2 times 3, it's going to be 6. Let me put an equal sign there so you see that I'm multiplying this by 2. 2 times 2 is 4, so 4 goes there. 2 times -2 is -4. 2 times 1 is 2. 2 times 1 is 2. 2 times -4 is -8. So now, if I double it, I'm going to have a point at 6, 4. So 1, 2, 3, 4, 5, 6, 4 is my new A. -4, 2 is my new B. And 2, -8 is my new C. And you see that this new triangle ends up being about twice the perimeter of the first one. Now that was multiplication. Let's now talk about adding two matrices. If we have, let's say we had a matrix like this, with a square matrix with 9 elements that look like A, B, C, D, E, F, G, H, I, and I wanted to add that to J, K, L, M, N, O, P, Q, R. Well, if I together, my new matrix would have the elements like this. I would add A and J, so it would have A in the first row, first column. I'd have A plus J, I'd have B plus K, I'd have C plus L, I'd have D plus M, E plus N, F plus O, G plus P, H plus Q, I plus R. So as you can see, I just added the elements from each matrix to give me my total of those two. So let's say I wanted to have this particular quadrilateral. Remember, quadrilateral is a shape with 4 sides. So let me make my line here, bring it down there, this line here for my axes, and I have a point at -2, -2. I have a point at 1, -2. Have a point at 1, -2. I'm sorry, yeah, -2, 1, I should say. And I have a point at 3, 4. So 1, 2, 3, 1, 2. It'll be my quadrilateral once I connect those points. Alright, now let's say we want to shift this 5 units to the right and 1 unit down. So what I could do is I could make a matrix out of the points. So we have the point -2, -2. We have, which represents x and y, by the way. We have a point at 1, -2. We have a point at 3, 4. We have a point at -2, 1. Now, since I want to shift this 5 units up, that means that I have to add 5 to each y value. So we're going to put 5s down here. If I want to shift it 1 to the right, that means I add 1 to all my x values. So we'll put 1s all up here. So what I'll do now is I'll just add the two matrices. I get -2 plus 1 is 1, or -1. 1 plus 1 is 2. 3 plus 1 is 4. -2 plus 1 is -1. -2 plus 5 is 3. -2 plus 5 is 3. 4 plus 5 is 9. 1 plus 5 is 6. So that's my new matrix when I add them together. Let's plot my points. I have -1, 2, or I'm sorry, -1, 3, 2, 3, 4, 9, and -1, 6. So you can see if I connect those shapes, or those dots, I now have a quadrilateral that has been shifted up 5 units and also to the right 1 unit. And actually, I think one of my points might be wrong there. Let me double check this. No, I think it's right. It was a little optical illusion there. So if you notice, every point is shifted to the right and every point is shifted up 5. So that concludes our lesson on the introduction of matrices and just some examples of how they're used. We talked about multiplying a number by them, and we also talked about adding them together.